So, what if the single most fundamental idea in economics was just plain wrong? Today, we're diving into something called nanoeconomics. It's this wild idea that to really understand the whole economy, you have to look at its tiniest, most chaotic, most unpredictable parts. All right, let's get into it.
You know this graph. If you've ever stepped foot in an Econ 101 class, you've seen the simple X of supply and demand a million times. I mean, it's the bedrock of microeconomics. But what if that clean, simple picture is actually hiding the messy, tangled-up truth of how our economy really works?
See, the whole reason that graph works is because of a little Latin phrase, ceteris paribus. It means all other things being equal. To analyze just one thing, like the price of coffee, economists have to pretend that everything else, inflation, new technology, your personal tastes, the weather, is completely frozen in time. It's a neat trick for a textbook for sure, but when is anything in the real world ever that simple?
Well, to try and tackle all that real-world complexity, a new field is being proposed: nanoeconomics. And it's not just a tweak to the old system. It's a fundamental shift in how we look at things, moving from that big, zoomed-out picture down to the smallest, most dynamic parts of the economic machine.
So what is it exactly? Well, nanoeconomics looks at the economy not as a bunch of big, broad markets, but as this incredibly complex system of tiny, moving parts. It's all about focusing on how these small, almost invisible interactions add up and combine to create the huge economic trends we see and feel every single day. And the goals here are pretty ambitious. We're talking about understanding how we use resources at a microscopic level, figuring out the real economic ripple effect of brand new tech, like, say, nanobots, and maybe, most importantly, building new models that can actually handle all this complex new information.
But to do all that, you need more than just a new name for a field. You really need a whole new philosophy. And that means letting go of some of those old, comfortable assumptions and learning to embrace a more chaotic, but, let's be honest, a much more realistic view of the world.
And this slide just cuts right to the chase. Traditional economics, it leans heavily on ceteris paribus, that world frozen in time. Nanoeconomics, on the other hand, is built on the exact opposite idea, omnia mobilis, which means everything is moving. It just starts with the assumption that the economy is never, ever standing still.
And this quote right here just brilliantly nails the core idea. The economy isn't always trying to find some perfect, neat, stable equilibrium point. No. Instead, it exists in a constant state of dynamic imbalance. Things are always pushing and pulling, shifting and changing, and never really settling down. And that assumption, that's the engine that drives this entire new way of thinking.
Okay, so if everything is always moving, how on earth do you even begin to graph that, right? That classic 2D chart just won't cut it anymore. This whole new philosophy requires a new kind of tool, a multi-dimensional model that's actually designed to capture all this constant motion. So let's build it, step by step.
First things first, forget the X and Y axes. This model starts with just a single straight line. And at either end, we put the two main things we want to measure. So let's stick with our original example. On one side, you have the quantity of a product people want to buy, and on the other, you have the quantity producers are willing to supply. They're basically opposing forces on the same spectrum.
Okay, now imagine a flat disk, like a CD, that slices right through the center of that line. This disk, it represents the entire economic environment, literally everything that could possibly influence our two outcomes. And it has two faces. One side is going to hold all the factors that affect demand, and the other side will hold everything that affects supply.
Now, this is where it gets really powerful. Radiating out from the center of that disk are a whole bunch of lines. Each and every single line represents an independent variable: price, inflation, consumer confidence, new technology, you name it. You can have 10 lines, 100, even, in theory, an infinite number of them.
And finally, the last step, we connect every single variable on that disk to both ends of our central axis. What you get is this complex, multi-dimensional shape, kind of like two cones stuck together at their base. But this isn't just some abstract art project. This is a model that visually represents how countless factors are all influencing supply and demand at the exact same moment. You can finally see the whole system in motion.
So, let's take this powerful new model and bring it full circle, back to our original problem, that way too simple supply and demand curve. What does the world look like when we finally stop pretending it's simple and actually embrace the complexity?
So, looking at the demand side, suddenly price is no longer the star of the show. It's just one factor among many. Now we can actually see how, say, a change in interest rates might change your decision to buy a car, or how the simple availability of more choices, that variety of products, pulls your attention in a dozen different directions. Every single one of these variables is a force, constantly shaping our decision to buy.
And you know, it's the exact same story on the supply side. A company's decision to make something isn't just about cost. What happens if a new raw material gets discovered, or a new technology suddenly makes production way cheaper? How do tax policies or inflation affect their bottom line? This model lets us see how all these things, from the number of workers they have to the depreciation on their equipment, all interact to determine the final supply.
Now, this is way more than just an academic exercise, right? Applying this kind of thinking, it really opens up entirely new frontiers for economic analysis. And it has some pretty profound real-world implications. This is the so what of it all.
So where could we actually use this? Well, the possibilities are huge. We're talking about fields like healthcare, the energy sector, even space exploration. Just imagine being able to model the precise economic impact of a new medical nanotechnology, or calculating the true value of using nanomaterials in manufacturing. This approach lets us see the tiny details that are driving our biggest innovations.
But at the end of the day, this is what it's all about. Nanoeconomics isn't just about making old models a little bit better. It's about giving us the tools to explore completely new questions, to shine a light on parts of the economy that have always been hidden in the noise, just too small or too dynamic to see with the tools we've had.
And that really leaves us with a fascinating final thought. For more than a century, we've had to simplify the world to make it fit our models. But with tools like these, we might finally be able to make our models complex enough to actually fit the world. And if we can do that, what seemingly impossible economic problems might just become solvable.